Hey everybody, your Friendly Math Tutor here with video 8 of our SAT one-sheet breakdown series. So linked below should be the PDF files for both the one sheet itself and the examples that I'll go through today. Subscribe to our channel. Check out our Instagram, Facebook, and TikTok accounts. And there you'll find more SAT videos, some AP Calc videos, as well as many, many other videos that we're going to continue to pump out through the years. All right, so let's dive into the one sheet for today. All right, so today's deep dive into the one sheet is going to be on part 4 formulas, and we're going to focus on the right side over here on the good to know formulas. So we're going to look at the first half of this, and we're going to focus on the quadratic formula, solutions to a quadratic, the vertex of a quadratic, and special factoring. So let's take a look at the quadratic formula. Now there are other ways to do this, but let's just use the quadratic formula here just to illustrate how we would use it. And what you can do is look to simplify first. Since we have 0 on the other side, we can divide everything by 3. So we get x squared plus 4x plus 2 equals 0. This is a 4. And now we can use the quadratic formula. So negative b would be negative 4 in this case, plus or minus the square root. B squared would be 16 minus 4 times a, which is 1, times c, which is 2. All over 2 times a. Well, that's 2 times 1 is just 2. So then I would do the radical next. So this is 16 minus 8, which is 8, all over 2. And finally, you want to take a look at the radical, and you want to simplify that. All right. So over here on the side, I'm going to take the square root of 8, and let's just review how we simplify radicals. We want to find two numbers that multiply to 8, and the first one is a perfect square. So that would be 4 and 2. And we do that because we can take the square root of 4, and that's 2. So 2 square root 2 is a simplified version of the square root of 8. So I'm going to write 2 square root 2, and now finally I can divide each of these by 2. So negative 4 divided by 2 is negative 2. And 2 divided by 2 is 1, so I just have a root 2 left. So that is answer choice A. You could also have used completing the square here, so check out, there's another video where I do go over completing the square. But for this one, I just wanted to illustrate how to do the quadratic formula. Look to simplify first, and that'll save you some simplifying towards the end. Or at least the size of the numbers that we'll have to simplify, though everything will be just a little bit smaller. All right, so next we are going to take a look at the solutions to a quadratic. So this is, I have the product one here is C over A, but the most common one that I've seen on the SAT is the sum. So this can save time, but the first thing we want to make sure is that it is in the format ax squared plus bx plus c equals 0, so the standard form. So to get this to look like that, I'm going to distribute the 4. So I'm going to get 4x squared minus 20x, and then I'm going to bring the 16 over. And then simply, if they want the sum of the solutions, all right, we could find them separately, either by factoring or possibly the quadratic formula. And I think this one we would need the quadratic formula. But instead of going through all that work and then adding the solutions together, this is why this formula is good to know. Because if you just know it, you can say the sum is equal to negative b. Well, negative 20 is 20. Over a is 4, and 20 over 4 is 5. So we just get the sum of the solutions without ever actually finding either solution. So it's a huge shortcut to know this formula. Now, it's not guaranteed that on your SAT they don't always test this concept, but it's very helpful to know. Also, if they ever ask the product of the solutions, we would just do C divided by A. That's why I also have this one here. But since the sum of the solutions is much more common, that's why I chose to use this one as our example for this problem. All right, let's keep it going. And the next one we're going to take a look at is the vertex of a quadratic, actually the next three that we take a look at. So the vertex of a quadratic, depending on the form, you could have something in standard form, something in vertex form, and something in intercept form. Each of them you find the vertex in a different way, and instead of having to convert back and forth between the forms and waste time, it's best to just know how to find the vertex in each form. So let's take a look at our first example based off of the vertex of a quadratic, our third example overall. The parabola of the vertex is a comma b is represented in the equation above. What's the value of b? So this is just, they like to change letters. This is just a fancy way of saying what's the y coordinate of the vertex. So the best way to find the vertex, this is in intercept form. That's what we have to know. When something is factored, it's in intercept form. And the intercepts are by setting each equal to 0. So if you set 2x minus 1 equal to 0, you will get 2x equals 1 and x equals a half. And if you set 2x minus 11 equal to 0, you will get 2x equals 11 and x equals 11 halves. So the best way to find the x coordinate of the vertex is to add up the intercepts and divide by 2. So you're essentially finding the average of the x-intercept. So the vertex, since it's symmetrical, the vertex is in the middle. So halfway through the average of the x-intercept, so add them up and divide by 2. So what we'll do here is do 1/2 plus 11 over 2 over 2. Well, that's 12 over 2 is 6, 6 over 2 is 3. But the answer is not 3. They want the value of b, which is the y coordinate. So now I'm going to just substitute 3 in. So I get 2 times 3 minus 1. And then the other one, I have 2 times 3 minus 11. That's 6 minus 1 is 5. 6 minus 11 is negative 5. 5 times negative 5 is negative 25. So when you have something in intercept form, you're going to find the x-coordinate of the vertex by just finding the average of the x-intercepts, because that's the middle, and again, a parabola is symmetric. So the next example for this same concept is something that's in vertex form. So you look at all of these answers, they are in vertex form clearly. And what we want is for h here to be 3 and k to be negative 8. So if I substitute that into the formula, I get y equals a times x minus 3 squared minus 8. So that eliminates b and c. Now we got to find the a value. Well, the best way to find the a value is to substitute a point that's on the graph. I'm going to choose this point, which is 5, 0, and I'm going to substitute it in. So 0 equals a times 5 minus 3 squared minus 8. So 0 equals 5 minus 3 is 2, 2 squared is 4, so 4a minus 8. Add 8 to the other side, 8 equals 4a. I think we can see that a is 2. So therefore, the answer has to be C. So in vertex form, you get the HK is the vertex, and the A value is what you get by substituting a point other than the vertex into the equation to solve for A. Okay, moving on to our last one related to the vertex of a quadratic. So here we want the maximum value. So if you have a parabola here, this is out of order, so I'm just going to switch it so it's more familiar looking to us. So this is in standard form, all right? So this fits standard form with a C value of 0. And this is a parabola that opens upside down. So you can see the vertex is the maximum value. So if they ever ask you maximum value or minimum value, that's just a fancy way of saying what's the vertex. And the actual value, v, is like the y value. So we're really finding the y coordinate, or in this case, the v coordinate of the vertex. So we start with the vertex of this formula, but here we have t instead of x, and that's negative b over 2a. And negative b is negative 5 over 2 times negative 1. So this is negative 5 over negative 2 is 5 over 2, or 2.5. So then what we're going to do to get the maximum value of v, we're going to do 5 times 2.5 minus 2.5 squared. So 5 times 2.5 is, I'm blanking on that one, 12.5? I'm going to double check that in the calculator. I definitely should know that. Yeah, it's 12.5 minus 2.5 squared, which is 6.25. And so 12.5 minus 6.25 is 6.25. So the maximum value of this is 6.25. All right, so again, to recap, just take a look at these. This one was in standard form, which is why I use negative b over 2a to find the vertex. And maximum value is just another way of asking for the vertex. And finally, we got our special factoring techniques. So these are just quick ways to factor instead of having to do FOIL. This one is, we're using the second one. It's something squared, like it's a binomial squared. So that way this one is n squared minus 8n plus 16. And on the other side, we get n squared plus 8n plus 16. All right, so if you can just be able to multiply these out. First of all, the mistake I usually see is, like, for instance, n plus 4 squared. I'll see a lot of times n squared plus 16. So that's just completely incorrect. But also I see a lot of, like, writing both out, like n plus 4 times n plus 4, which is totally fine, and doing FOIL, but that just takes a little extra time. So this is why it's good to know that if you want to expand something out, it's just the first one squared plus 2 times them multiplied together plus the last one squared. And then from here, we just do some canceling. We get up, I can add the 8n to the other side, so I get 0 equals 16n. Divide each side by 16. And you get n equals 0 over 16, which is 0. Now, you may have been able to look at this and say, well, if I have something squared, 0 just makes sense, because then I'd have negative 4 squared equals 4 squared, which is both 16. That's totally fine. But if you don't see that, then you've got to solve it, and this is just a little bit of a shortcut to use your special factoring. The first one, I didn't do an example of that, but that's called a difference of two squares. That's anytime you have x squared minus y squared is x plus y, x minus y. So just recognizing both of these and being able to use them just can save you just a little bit of time, which is, again, what I think is good to know. So to just do a quick recap, quadratic formula, you're going to use that when things don't factor. You can use completing the square, but also if you don't remember completing the square, you definitely should know the quadratic formula. The solutions to a quadratic, if they want the sum or the product, instead of finding them individually and then doing the sum or the product, it's a lot easier just to know these formulas. The vertex of a quadratic, you don't want to have to change between forms. You should never have to change between forms because that just takes time. If it's in standard form, use negative b over 2a. If it's in vertex form, use hk. If it's in intercept form, find the average of the intercepts. Those, for the first and third ones, that gives you the x value. If you need the y value, you got to plug it back in. And they could ask for minimum or maximum value. Those are kind of like code words for also finding the vertex. And then at the bottom here, just our special factoring. I think that's that can be just really helpful to, again, just save a little bit of time on either factoring or expanding. All right. I hope that was helpful. Check out our other videos to this series, as well as all the videos that we put out on Instagram, TikTok, and Facebook. There's a bunch of SAT stuff out there. There's BC calculus stuff, and there's going to be a lot more in the years to come. All right, so again, hope that was helpful. Have a good one.